For the major run here, we are on 10.8, the last section in chapter 10, dealing with inequalities. And we have done graphing inequalities, writing inequalities, graphing inequalities with absolute values, graphing equations with absolute values, graphing linear inequalities, and now we're going to be graphing systems of linear inequalities. So we're just going to do the same thing for 10.7 that we did for 10.8, and we just need to understand, again, it needs to be true for both, so it's an AND statement, so we need to find where is it true. So we get these two equations, we're going to put them in slope-intercept form, we're going to graph them. Some will have dotted, some will be including, but we have we graph both of them, and then we look and see where is it true. So we have to test twice. We have to test for each of the lines to find out which way we're shading, and then wherever we see the true, then that's going to be our solution. You see the double graph. So this makes it hard to see, so we won't be extending our lines like that. This is false. This is true for this line, but false for this line. This is true. This is true for this line, but false for this line. And as I said, that's false. So that's what we're going to be doing. They give us two linear, two horizontal and vertical lines. So y is greater than 0. Oh, and on the axes. Okay. So it goes through the y-axis at 0. It's going to be an open. Oops, sorry. Oh, let's do colors. We'll do that in green, that in blue. So we'll do that green. It's going to be an open circle. Open circle. We have a dotted line right along the x-axis because that is where all our y values are 0. We're going to test. Now we can't test 0. Speaking of testing, they're testing our metal. We will do 0 for x and 1 for y. That's this point right here. Whoops, sorry. I don't want it to be green just at the moment. I should probably do blue, huh? Or purple or some other red. Well, we'll try it. So we're going to test out. We have 1 is greater than 0. That is true. So this point is true. Now I'm not going to extend it all the way out. What I call are these little teeny hairs. That at least tells me this side of the green equation that we're going to shade. Oh, we'll do this. We'll just keep it. X is greater than or equal to 0. So where is x equal to 0? It's right on it, and it's going to be a solid line. It's going to go through that. We can't test 0, so we will test 1, 0. 1 on the x, 0 for the y. And then if we plug that x value in, is 1 greater than or equal to 0? That is true. So we know this point is true. Okay, so we'll make little hairs to represent the true side of this line, the true side of this line. And so where is the solutions? Where is it true? That's going to be in this area. So this is the solution. So that is all the true. This is true for green, false for blue. This is false for blue and false for green. This is true for blue, false for green, and this is true. Okay, so that's how we do it. Let's graph that in green, this in blue. Let's do the green. Closed circle on the y-axis at 3, and all of them where y is going to be 3 would be this. We're going to test, this time we can test 0, 0. So 0 less than or equal to 3, that's true statement. 0 is less than, so we're going to shade down towards it. So it's true for green. Let's do the blue. At 2, x is 2 right here. That's equal to, so we can do that. That will be a vertical line along there. Let's test the point. 0, 0 is 0 greater than or equal to 2. That is going to be false for blue. So, I don't know, right? F for false for blue. So we're going to shade the other side. And where is it true, true? This is false, false. True for blue, false for green. True, true. True for green, false for blue. So it is going to be right in this area. That is the true, true. I really don't enjoy the horizontal and vertical. Whatever. Green, blue, green, y is greater than 2, so y-axis is 2. That's going to be an open circle dotted along that horizontal line. Let's shade. So we're going to test 0, 0. My y value is 0. Is 0 greater than 2? That's false. So this point is false, so we're going to shade up. Maybe I just don't show and we just understand. I don't want it to be too noisy. Whoops. X is less than -1. That's going to be x-axis is -1 here. That's going to be an open circle. We're going to have a vertical dotted line. Let's test 0, 0. We have 0 for x. Is 0 less than -1? That's also false. This is better. So 0 is false, so we'll shade the other side. But see, I miss out on that visual of false, false. But it is false, false, because when I tested this point, it was false for green and false for blue. So this is going to be where they share true trues. Green, blue color, green, -2, open circle. That didn't look like an open circle. That looks like a closed circle. -2, dash, dotted, dash, whatever you want to say that. Testing 0, 0. Is 0 less than -2? That is false. That point is false, so we will shade the other side with the little whisker hairs. X is greater than 2, so open circle. Whoops, that's y, Mr. Mac. That is +2, open circle, dotted, vertical. Let's test 0, 0. X value is 0 greater than 2. That is false. A lot of falses here, people. False, so the other side is true. And we see where it is true, true. Okay. Oh, that's interesting. So I'm going to rewrite this. That's very interesting. I'm just going to rewrite it so I can see what the slope equals 1 and the y-intercept equals 0. Oh, this will be good too. So we'll make that green. This is green stuff. And this has a slope of 0 and a y-intercept of 1. We'll make that blue. That information blue. So green has and it's open circle at 0 and a slope of 1, up 1, right 1, up 1, right 1, dotted through there, through there. Can't test 0, 0. We have to test I'm going to test negative 1, 1. So my x value is negative 1 less than my y value. That is true. So that point is true. So I'm going to shade this side of the graph towards that true point. Let's go blue now. You're my boy. Y-intercept is 1. It's open. And slope of 0. So up 0, right 1. So that's going to make a dotted line like this. I can use the point 0, 0, so I can test 0, 0. Is 0 greater than 1? That is false. Blatantly false. So 0 from this perspective is down here. That's false, so I'm going to shade up away from my point. And now, where is it true, true? Up in this area. Ooh, that's a lot of... Okay, that's the true, true. There's a lot of problems in this one. Okie dokie. Let's do this first. This has a slope of 2, a y-intercept of 0. This has, oh, that's not, that has a no slope, and an x-intercept of 2. So they're being tricky. Let's do green. Y-intercept of 0, open circle on the y-intercept of 0, slope of 2, up 2, right 1, up 2, right 1, dotted, can't use 0, 0 to test. Testing, negative 1, 1, just up in this region. Is 1 greater than or equal to 2 times negative 1? Is 1 greater than negative 2? That is true. So 1, 1 is true, so we'll shade this side. This is x-intercept of 2, x-intercept of 2, open circle. It's going to be a vertical line dashing through the snow. Let's test 0. My x0 is 0 less than 2. That's true. So that's true. So we're going to shade towards the true from this boundary line. And the true, true is going to be through here. Can we get just a normal line, please? Normal equations. Okay. We're going to have to do some work on that first. Let's do this. Let's rewrite it as y is greater than or equal to negative x plus 3. Let's shade that in blue. This is going to have an x-intercept of 2, and this time we're going to include it. So x is 2 right here. Vertical line, testing. 0, 0 is 0 less than or equal to 2. That's true. We're going to shade to the left on the boundary. Let's do this. This has a slope of negative 1, a y-intercept of 3. Open circle on y-intercept of 3, 1, 2, 3. Open circle, down 1, right 1, down 1, right 1. That's going to be dotted. And testing. 0, 0 is 0 greater than 3 minus 0. Is 0 greater than 3? No, that's false. So 0 is false, so I'm going to have to shade the other direction. Just with these little baby 3-day shave. And so inside here is going to be where it's true, true. They continue to test my patience with these formulas, with these inequalities. So x x is negative 1 here. That's an open circle dotted on x is negative 1. Let's test 0, 0 is 0 greater than negative 1. That's true. So we're going to shade towards 0, 0. This has a slope of 2, a y-intercept of 5 equal, so that'll be a closed dot on my y-intercept, 1, 2, 3, 4, 5, with a slope of 2, up 2, right 1, up 2, right 1. Let's make that nice solid line. Testing. 0, 0 is 0 less than or equal to 2 times 0 plus 5 is 0 less than or equal to 0 plus 5 is 0 less than or equal to 5. That is true. So this point, let's shade this way. Do you see why it's beneficial to just do the little teeny hairs? You don't need to extend it, or else now you're going to be confused on where is the true. And here we see where the true is on that. I guess we could use highlighters too. That would be very, very nice. Should I do that for this one? How many more are left? Oh my goodness. You got to be kidding me. What are we doing here? That's a lot of problems. For a lot of heavy lifting here. Am I complaining? Maybe a little bit. All right. Let's do y-intercept of 2. So we have a dot here. We have a slope of 1. Make a dot. Make a dot. We can extend it. So there is my line. Ooh, that's kind of nice. Let's test. We may have to do that here. Test. 0, 0 is 0 less than or equal to 0 plus 2 is 0 less than or equal to 2. That's true. So we will shade. Well, let's do little shades. That's true. So that's this way. So we'll do little highlighter, a little highlighter. And let's do this. That's not really good, but that's going to be y is greater than negative x plus 1. That has a slope. That's a y-intercept of 1, open circle, and a slope of negative 1, down 1, right 1, down 1, right 1, dotted, dotted. Let's test 0, 0. So testing 0, 0 is 0 greater than 1 minus 0 is 0 greater than 1. That's false. So that is false. So we're going to shade the other way. And then if we want to show where is true, we can do it like that. That's not bad. That maybe was over the top, but that's okay. So, I hope, no, that's not parallel. We should know when they're parallel. That would be a fun one. Parallel lines, where you get it. Yes, that's so good. So let's do green. Y-intercept, open circle at 2, slope of up 2, right 1, up 2, right 1. Two, also open circle, slope of 2, negative 2, so down 2, right 1, down 2, right 1. These are not perpendicular because perpendicular would be opposite, reciprocal. And, oh, I didn't test. Yikes. Let's test each of those. Testing. 0, 0. We get 0 less than 2 times 0 plus 2 is 0 less than 2. That's true. So we're going to shade towards the true. That's towards 0. We are testing 0, 0, 0 greater than negative 2 times 0 plus 2, 0 greater than 2. That's true. Oh, what? That's not true. 0 is not greater than 2. That's false. Pay attention. So that's false blue, so I'm going to go up away from 0, 0. And again, the intersection is here, into this space. This one, this one. -1, open circle. Slope of 2, up 2, right 1, up 2, right 1. Let's test this time. Testing. 0, 0 is 0 greater than 2 times 0 minus 1 is 0 greater than -1. That's true. So we will shade towards the true. Let's +2, open circle, up 2. Oh yeah, here we go. Same slope, parallel lines, up 2, right 1, up 2, right 1. So this is going to be fun to see. I like these. These are the 1%ers. So we're going to test 0, 0 is 0 less than 2 times 0 plus 2. 0 is less than 2. That's true. So we're going to shade that inside. Inside. So where is the intersection? Right in here. Boom. That is the solution. Right in between those two parallel lines. Yeah, that's so cool. So you wouldn't have known it if you extended them out. You would have been, there would have been so much noise. You wouldn't have been able to figure it out. Can we have a closed circle or an equal sign somewhere along here? 4, 1, 2, 3, 4, open circle, 1, 2, 3, right 1, 1, 2, 3, right 1, dotted, dotted, testing, test, 0, 0, 0 less than 3 times 0 plus 4, 0 less than 4 is true. Let's graph it this way, shading towards my true. Nope. Let's go blue. Oh, well, sorry. Let's rewrite that in y is greater than -3x plus 3. Now we'll put that in blue. Slope, y-intercept is 3, 1, 2, 1, 2, 3. Ugh, right on top of each other. Down 1, 2, 3, right 1, 1, 2, 3, right 1. Oh, we forgot to test. Oh, I tested that. I need to test this. Test. I can test 0, 0 is 0 greater than -3 times 0 plus 3. 0 greater than 3, that's false. So we're going to shade away. Shade away, it sounds like a song. And shade away. Also, again in here, they like this area here. Okay. Oh, standard form. So cross-hatching, I like that. It is called cross-hatching. We're going to isolate, I'm going to, well, okay. X minus y is greater than or equal to 2. Let's add the y over just to make it easy. X, and let's minus the 2. X minus 2 is greater than or equal to y, which becomes y is less than or equal to x minus 2. Let's do this equation. Can we move you a little bit around? Okay, let's do this other equation. X plus y is less than or equal to 4 minus the x, y is less than or equal to negative x plus 4. Let's give each one a color. We'll make that green, make you blue. Green has a, equal signs, yay! -2, closed circle, slope up 1, right 1, up 1, right 1, solid line through here. Testing the point, test 0, 0 is, well, that wasn't 0, 0, that's just 0. 0, 0 is 0 less than or equal to 0 minus 2 is 0 less than or equal to -2. That's false. So we're going to shade the green away. Closed circle on 4, 1, 2, 3, 4. Slope of down 1, right 1, down 1, right 1. Those are going to be perpendicular because they have slopes that are opposite reciprocal. And we're going to test the point 0, 0. What did we say? Oh, we used that equation. Okay, 0 less than or equal to -0 plus 4. 0 less than or equal to 4. That's true. So we will shade towards the true value. And we see that the crosshatch is there. Those are both in standard form. Let's take x plus y is greater than or equal to 3 minus the x. Y is greater than or equal to -x plus 3. Let's move you again. Let's move it up here. Let's take this equation. X minus 2y is greater than 4. Let's add the 2y over and minus the 4. We get x minus 4 is greater than 2y. Divide by 2, divide by 2, divide by 2. 1/2 x minus 2 is greater than y. Let's write y is less than 1/2 x minus 2. Yeah, I probably made it harder than it needed to be, but it's okay. Closed circle here at 3, 1, 2, 3. Slope of -1 gets us here, here. We're going to connect that dot. We'll make arrows. Let's test, see which way we're going to shade. 0 greater than or equal to -0 plus 3. Is 0 greater than or equal to 3? That's false. Let's graph away. -2, but it's open circle. Slope of up 1, right 2, up 1, right 2. Dotted line here. Sorry. Dotted line. Testing. Test. 0, 0 is 0 less than 1/2 times 0 minus 2 is 0 less than -2. That's false. So we will shade away from that. Where are they both? Right in this little pocket. 4 more. 4 more and then we're done with chapter 10. Oh, no, standard form. Let's move you over here. Standard form. 2x minus y is greater than -1. Let's add the y to both sides. Let's add the 1 to the other side. 2x plus 1 is greater than y, or y is less than 2x plus 1. X minus y is greater than -2. Let's add the y. Let's add the 2 to the other side. X plus 2 is greater than y. Let's write y is less than x plus 2. I think I did that correctly. With that, both are open circles. At 1, slope of 2, that looks like it's closed. Up 2, right 1, up 2, right 1. dotted. Testing, test, 0, 0, 0 less than 2 times 0 plus 1 is 0 less than 1. That's true. We will shade right. That's kind of close, but we still know 0 is that direction. 2, open circle, up 1, right 1, up 1, right 1. Ugh, that is so close. Why would you do this? Testing, 0, 0, 0 less than 0 plus 2 is 0 less than 2. That's true. So we're going to shade that down towards 0. And the double intersection where the true is in this region. All right, standard form. Here's another way. We can keep it in standard form. I'll do this one in standard form. So we use y-intercepts and x-intercepts. We're going to solve. So the x-intercept, well, that's too bad. X-intercept is 5. We do the cover-up method. So we cover up the y because x-intercept y is going to be 0. So we get y equals 5. So on x equals 5, 1, 2, 3, 4, 5, open circle. My y-intercept is going to be negative 5. So on the y-axis, 1, 2, 3, 4, 5, open circle. We can connect those dots. And that is how we do that. That's nice. It's kind of convenient. We're going to test. We're going to test 0, 0 is 0 minus 0 less than 5 is 0 less than 5. That's true. So we're going to shade towards the true. Now we're going to use the standard form. We're going to find our x-intercept is 6, also open, right next to 5. Thanks again, not helping me. My y-intercept is going to be negative 3. 1, 2, 3, negative 3. Now we come through this area here. Let's test. 0, 0 is 0 minus 2 times 0 greater than 6 is 0 greater than 6. That's false. So we're going to shade away. So in here. And my shaded, double shaded solutions are going to be there. Yeah, we could still, okay, this will be fun. Yeah, we can't do it with that one. So we can still do this. My x-intercept is going to be negative 3. So x negative 3 is there. My y-intercept is going to be positive 2. So see how fast we can just look at that. And testing, 0, 0. We won't even show that. Testing is 0 less than negative 6. That's false. So we're going to shade away. So notice we can do a lot of this mental math. This one we can't because my y-intercept is going to be 0. And that's open. And my x-intercept is going to be 0. So I'd have the same point. So we are going to have to solve that. So let's minus 2x, minus 2x. You get 3y is less than negative 2x. Divide by 3, divide by 3. Y is less than negative 2/3 x. So it has a slope of negative 2/3. So down 1, 2, right 3. Open circle, down 2, right 3. 1, 2, 3. Dotted. Dotted, dotted, dotted. We can't test 0, 0, so we have to test something different. We're going to test something out of that quadrant, like 1, 1. So if we test 1, 1, we get 1 is less than negative 2/3 times 1 is, is 1 less than negative 2/3. That's false. So 1, 1 was here, 1, 1 was here, so that's false. So we have to graph the other side. And that's where you have to be quick. That's where you got to be on your game and understand how to find information when it's not in a typical slope-intercept form. Yeah, that's 0 again. And we could do that one, so we'll do this one. Unfortunately, so we can get 0 for the green, but we're going to have to manipulate this equation. So that's going to be, we'll add y to both sides. We get 2x is greater than y, or y is less than 2x. Still has a slope of 2, so I can use that. I'm going to go up 2, 1, 2, right 1, up 2, right 1. That's through the origin, so I'm going to have to test something other than 0, 0. So let's test, whoa, red, not red. Let's test negative 1, 1. So that gives me 2 times negative 1 is greater than 1, negative 2 greater than 1. That's false. So that point here, negative 1, 1 is false, so I'm going to shade the other side of the border. I can use this. This is in standard form. That has an x-intercept of negative 6, closed circle, negative 6 for x, 1, 2, 3, 4, 5, 6, closed circle, and a y-intercept of positive 3. 1, 2, 3. We can connect the dots here. We can test a point. We can test 0, 0. I did it again. It's not a function. So 0 minus 2 times 0 less than or equal to negative 6 is 0 less than or equal to negative 6. That's false. So that point is false, so let's shade away from it. And the crosshatch is right up here. And that is graphing or systems of linear inequalities. Yep. Congrats, you've finished chapter 10. You should be pretty proficient at it. This is good stuff. I mean, these are on most of the placement tests. This is stuff that is very relevant. Good luck.